In our previous video, we have seen how Surds calculation works, especially multiplication, simplification, and addition and subtraction. Today, we are going to see if we have brackets in Surds or Surds inside the bracket, how we can calculate them. First of all, let's start with single brackets. Let's say, first example, we have Surd square root of 7 that is multiplied. Inside a bracket, we have 3 plus square root of 3. So how do you do it? We exactly follow the algebraic rule of multiplication, but we just use Surds rule when we multiply them. First of all, let's multiply this integer 3 with this surd square root of 7. We know that they are multiplied, but the integer will be written in front, and then we will have to write the surd there. So now let's multiply two surds. We have the plus inside. With two surds, square root of 7 will be multiplied by square root of 3. When both of them have square root, we can just put one square root and then we can multiply the number inside. So 3 will be multiplied with 7, then we are going to get 21. So that's it. That's how you can multiply them. Now let's see another kind of example. Let's say this time we have square root of 3. This is multiplied with, let's say, 2 plus 3 square root of 4 or 3 square root of 5, let's say. Okay, so we have the same thing, but now we have an integer in front, but the procedure is same. Integer multiplied by the surd, the integer is written on front, and then comes square root of 3. Then the plus, we have an integer, there is nothing in there, so we just write that integer there, and one square root, the surds get multiplied, we get square root of 15. Okay, let's see another one. Let's say as example 3, we have 4 square root of 3, that is multiplied by square root of 3 plus 3 square root of 3. So how do you solve it? Let's see. First of all, we have one integer, there is no integer there, or we can say 1 is there, so 4 multiplied by 1. It's not something, there is no integer with this surd, so we just consider that 1 is the integer there. So 4 multiplied by 1, we have the 4. Then we multiplied by the surds. Square root of 3 and square root of 3, you have, if you have seen the previous video, know that when we multiply the same surd, we get the integer only. So square root of 3 multiplied by square root of 3 is just 3. Plus, we do the same thing here, but we have an integer there which is 3, gets multiplied with the integer of the outside 4, so we get 12, multiplied by, again we have the same surd, when they get multiplied we get the same number. So ultimately you are going to get 12 plus 36, which gives us 48. Okay, now let's see the last example. 4, let's say we have square root of 5, that is multiplied by 3 minus square root of 8. We do the same thing, the integer comes in front, then the square root there, then minus, we have two square roots, we take one square root, 8 multiplied by 5 is 40. At this stage, you need to be careful because you may think that the math is done, it's not done yet. If you can simplify, you have to simplify, and we can simplify this one. Let's see how. So 3 square root of 5, we know that 40 can be written as square root of 4 multiplied by 10, or square root of 10. Then we can just divide that thing with separate square roots. Square root of 4 multiplied by square root of 10. Why did we do that? Because if in our previous video we talked about it, that whenever we can dissolve one of the surds, we will dissolve one of the surds to simplify it. And 4 is a square number, so square root of 4 will give us 2. That's why we did it. Now you can easily have that answer, 3 square root of 5 minus square root of 4 is 2, so 2 square root of 10. So that's your answer. This is how you can solve all the single brackets using the surd formula and a little bit of tweak from the algebra. Now let's look at some double bracket questions and how we can approach with double brackets. First of all, in example 1, let's say we have square root of 3 plus 4, that is multiplied by square root of 3, let's say minus 2. So we approach just like algebra. One component of the first bracket gets multiplied with all the components of the second bracket. So square root of 3 is first multiplied with by this square root of 3, and we know that they are the same surd, so we are just going to get the integer. Now square root of 3 will be multiplied with the negative 2, so we have minus 2 square root of 3. Now our square root of 3 is done, so let's move on 4. So 4 will first get multiplied by square root of 3, so we are going to have plus 4 square root of 3. Then this 4 is going to get multiplied with the negative minus 2, so plus minus is minus, so 4 multiplied by 2 we simply get 8. But here we have like terms. Just consider square root of 3 as x. Then you have minus 2x plus 4x. Just like that, you can just simplify the middle portion here. And we also can simplify minus 8 plus 3 is going to give us negative 5. And negative 2 square root of 3 plus 4 square root of 3 just going to give us positive 2 square root of 3. So this is how we can approach this one. Now, let's see another kind of example. Let's example 2. We have square root of 7 plus 2, and this is inside a bracket, and this is multiplied by another square root of 7 minus 2. Let's see how we can approach with this one. Again, the algebraic thing, first component gets multiplied with all the components in the second bracket. Square root of 7 gets multiplied with square root of 7, we are just going to get 7. Now square root of 7 gets multiplied with negative 2, we get minus 2 square root of 7. Now our square root of 7 is done. Let's move on to positive 2. So positive 2 multiplies with square root of 7, we get 2 square root of 7 positive, and then plus and minus is minus, 2 and 2 gets multiplied, we get 4. So ultimately we can just solve 7 minus 4, both of them are integers, we get 3. And then look at 2 square root of 7 plus 2 square root of 7, but one is positive, the other one is negative. They will just finished, they will get subtracted, and both of them are finished. So it's like minus 2x plus 2x, we get nothing. So 3 is your answer, and this one will be cut because we have the same component. This is how we can solve double brackets. But let's look at another kind of example in double brackets. Now let's solve the last example of the double bracket. We have square root of 2 plus square root of 5, that is multiplied by 7 minus square root of 10. So first of all, we're going to take this square root of 2 and multiply all the components between the second bracket. So square root of 2 multiplied by 7 is 7 square root of 2. And square root of 2 multiplied by minus 10 is that 1 square root, and 2 and 10 gets multiplied, so minus 20. And then let's move on to square root of 5. Square root of 5 multiplied by 7 is 7 square root of 5. And then square root of 5 multiplied by minus 50 minus 10 is minus 50. So square root of minus 50. So let's say approach this one. It is not as simple as it seems because 20 can still be broken. We can simplify 20. How can we do that? We can simply put square root of 4 multiplied by square root of 5, right? Okay. 7 square root of 5 cannot be simplified. Let's keep it like this. And 50 can be simplified. We can write square root of 25 multiplied by square root of 2. We took 25, we could have written 5 and 10, but 5 and 10, none of them are square values. So we choose 25 because 25 is a square number and we can square root it. Just like that, in 20, we could have choose 2 and 10, but we did not. We choose 4 instead because 4 is a square value, we can square root it. So let's see how it looks. 7 square root of 2 minus, when 4 is square rooted, we get 2, so 2 square root of 5 plus 7 square root of 5 cannot be simplified, it stays like that, minus this 25, when you square root it, you get square root of 5, sorry, only 5. So 5 multiplied by square root of 2, so 5 square root of 2. Now, do we have simplification here? We have like terms. We have 7 square root of 2 minus 5 square root of 2. So just consider that square root of 2 is x, so 7x minus 5x, we're going to have 2x, so 2 square root of 2 there. And we have minus 2 square root of 5 plus 7 square root of 5. So we are left with 5 square root of 5. So this is how, even if you have this kind of a little bit of complex problems, you can solve them. Just look for simplification. When you break them, so let's look for that you have square numbers there. If you have square numbers, you can actually resolve the surd and get an integer. Whenever you have an integer, you can just simplify the math and get your answer like this. Sometimes you may see questions like this. You may get a power on your bracket, just like this one, we have a square power. Don't get confused, it's actually double bracket question. This can actually be written as square root of 5 plus 2, and the square means that this thing is repeated twice and they are multiplied. So square root of 5 plus 2 again, and we multiply it in the standard way that we learned. Let's do it. So square root of 5 multiplied by square root of 5, we have just 5. Square root of 5 multiplied by plus 2, so 2 square root of 5. Then we are done with the square root of 5. Let's move on to 2. 2 multiplied by square root of 5, another 2 square root of 5. And 2 multiplied by 2, the integers are multiplied, we just get 4. And when you solve it, you get 5 plus 4, the integers are added, 9. And we have 2 square root of 5 and 2 square root of 5. In total, we have 4 square root of 5. So just like that, whenever you get questions like this where there is a square, you can still solve it. Even if they are cube, you can solve it, right? So this is how we approach all the single brackets and double brackets in Surds. And I believe that from now on, you're not going to have any issues when you're calculating with Surds and brackets. Now that you know how Surds calculation work and how Surds with brackets work, the next one is going to be very important for you, and I recommend you watch that video too. In our next video, you will learn how to do rationalizing the denominators. So do watch that video and it will complete your Surds series. Until then, bye bye.